Okay. So what I said yesterday was that we're only going to look at this truth table and we'll only care about when the output is a 1. So here, here, and here. The output, when I say output, I mean the y. Okay, that's a 1. So we do not care about the value when it's a 0. This guy here, we don't care. Why? Because this guy here is a 0. So we don't validate it. So now to extract an equation, what we have to do, so let's take the first one as an example, right over here. We have a, which is 0. Remember you said yesterday, we're using binary, it can either be 0 or a 1. Well, when it comes to variables, and let's say variable a in this case, it can either be a or a naught. If this 0 right here would have been a 1, it would be an a. But since it's a 0, it's an a naught. Are we okay with that? All I'm looking at right now is just this row right here.
Because it has the 1, right?
Because the y is a 1, we're going to look at these two values, and since both of these are 0, a will be a naught, and b will be b naught. Okay? So a naught, and so when you're multiplying, you don't have to put the multiplication in between. When you put two variables together, there's no plus sign in between. The multiplication is implied. Okay? So we have a naught, b naught for that group there. So that's only the first row. Then we have the second row. Okay? The second row, which we're going to OR the first row to. So remember, I didn't show it, but there's a multiplication there. Okay? Whenever you have two variables together, it's multiplied. So, Sardi, here I've got an A, and the A is a 1.
Yeah,
if the A is a 1,
it's a regular A.
It's an A. It is not knotted.
Yeah. Then you're
and now we're looking at this square here, this square here. Your B is a 0. If your B is a 0, then we have a knot.
I don't understand something. Let's say the first one, right? Why?
When you say the first one, are you talking about the first row?
Yeah. 0, 0, 1.
Yes.
Why don't you? Why do we do A naught and B naught? Why can't you do just A plus B? One
group, that first row is a group. All the variables within that group have to be multiplied, so they're ANDed. All the three groups that you see here, the three rows, that row, the third row, and the fourth row, okay, they have to be ORed together. Okay, so basically, if I had three variables be here, it would be A naught plus B naught plus C naught. A naught times B naught, sorry, times C naught. And then ORed again with the next one. Okay, so within a group, a horizontal group, a row, you always multiply. Between group to group, you OR.
Okay. No, just because you could get the same, technically, I think, you get A naught plus B.
No, you can't do that. He wants to cancel them out. You can't do that.
No, because if it's plus, then it switches to a 1. Y becomes a 1.
You're thinking way too much for this exercise here. We're not at that stage yet. Right now, all you're doing is extracting the equation, and this is the way you extract the equation. You have this row here. You're thinking ahead. You only start thinking the way you're thinking once you start wanting to solve for this. Right now,
I just have to
see
say
it as
something.
it is. Your A is a 0, it's A naught. Your B is a 0, it's a B naught. That's it. It's this.
Yeah.
This one here, your A is a 1, it's an A. Your B is a 0, it's a B naught. That's it.
Yeah, I just have to say something. If you can't,
go ahead.
You can't touch this stuff without using those theorems and laws that you gave us. You can't like cancel anything out or anything, right?
You could, as long as it's mathematical. If you can do it, If it's algebra, you could do it. But I mean,
Okay.
they're just about all present there with the theorems and the Boolean laws that I gave you. They're pretty much all there. Even the
Right.
factoring out, which I use a lot, is there.
So you can use, at the same time, you can start simplifying right away if you want, though. But,
Look, I want to see
Yeah.
everything before I start. It doesn't make sense to start doing it now. Okay,
I'm not
let's
doing
see.
that.
Let's see. I'm just saying. I'm just telling you all. Have the unsimplified equation, which you're going to be graded on anyway. You need this. I'm asking you for the unsimplified. So give me the unsimplified before you start thinking about how you're going to start getting rid of some certain variables. Okay, so here, Ellie, this third row right here, A is a,
Plus, just regular. A plus B.
it's a 1.
A times B, I mean.
So A multiplied by B. Why are they not knotted? They're not knotted because they're 1s. It's as simple as that, guys. If you have an A that's a 0, it's an A naught. If you have an A that's a 1, it's an A. If you have a B that's a 0, it's a B naught. If you have a B that's a 1, it's a B. That's it. This is the easiest part, okay? Don't complicate it. A naught is a 0. B naught, if it's a naught, it's a 0. If it's not knotted, meaning if it's just an A, it's a 1. If it's a B, it's a 1. That's it. Don't complicate it any more than it is. There's a lot more complicated stuff than that. Save it for that. Okay, I'm going to erase these. Now we want to use the laws and theorems. What I recommend to you, okay, is to try to factor out. You can still use the laws and theorems. Here, I can put this on the side here. I'm going to try to open up. Okay, if you remember yesterday, I gave you the handout with all the last sheet of Boolean handout. This guy here. So if you go to the last page of this document, they're all there. Okay, but what I use a lot is Law 5 here. Law 5 is factoring out. What's common with this guy and this guy here? The A's. So look, I can do that right here. Can I factor out anything between this and this? Do they have the B naught? Okay. Yeah. Forget about this. I'm not touching this guy here. I'm not even talking about it. Okay. So I could factor out the B naught. Squeeze in a B naught right over here. Once I remove or factor out the B naught here, what am I left with?
A naught.
A naught. I'm going to plus. Well, if I factor out the B naught here, I'm left with an A. Right now, I'm just touching these two. That's it. I have not touched this guy. I have not touched it yet. Okay. So far, are we okay? Most of them, before you say anything, yes, there's one step I can use here, but I'm just going to take it slow, okay? I'm going to use several of them.
Yeah.
Because you could have used Law 9. But I want to simplify it. If you factor out, you have groups, you factor out a variable or two variables if necessary, if possible, then go that way.
What's the name of that document you have that you just opened up?
This one here, it's entitled 3 Boolean Algebra Tables. Here, look at the screen. Let me just bring it over. So under day 1, you see this? This guy here.
Oh, PDF. Okay.
Yeah. Okay, so now I'm going to apply one of these theorems. We said yesterday that if we had an A naught plus A, so if you look at T8, do you all see T8 here? I have A naught plus A. What's the result? 1. If you want, I'll tell you why it is what it is, okay? I'm going to erase this afterwards. That's an OR gate. And this is why this works. Okay? Instead of memorizing, I use a lot of logic as well. If that wasn't there, I'd still know that it's equal to 1 because I remember what an OR gate does. If I have an A and an A is 0, is everyone paying attention, please? That means that this guy is 0. And since this guy is 0, this is A naught, that's a 1. And with an OR gate, based on what I showed you this morning, in an OR gate, as long as one of the inputs is a 1, what's the output?
1.
A 1. If my A would be a 1, so let me get rid of this guy, and this guy, and this guy, and this guy. Okay, draw. So if A was a 1, well, this guy here is a 1. This guy here is a 1, this guy would be a 0, but I still have a 1 and a 0. It's an OR gate. The output is a 1, so I can replace this with a 1. Do you understand why this can be replaced by a 1? Do you understand why this guy here exists, T8? Okay, that's why it exists. The work is done for you. Just apply it.
Sir.
Yes.
I have a question, sir. Yesterday, I don't understand about this. In your, how to say, in your formula, give me the Boolean Algebra table.
Yes.
Yes, on the left is the theorem, yes, sir?
Yes.
And the right is the laws, yes, sir?
Yes.
So I try to prove the laws from the theorem. The theorem, I mean, I want to prove the laws, use the theorem, but about some laws I can't prove from the theorem.
They can all be proved. And if you want, we can stick around today and we can prove them together. Tell me which one you're having difficulties with. Which one? Or I'll the
error 15. Error 15.
L15?
Yes.
Okay. It's not that I don't want to do it.
Oh no, not this. Not this.
We can do it today at past 11 o'clock. You and I can do it. Trust me, all these work. Okay. It's if you look at law 15. If you look at law 15,
error, yes, error
okay.
15.
Do you know what you have to do to prove it?
I'll try my best. I can't prove it.
Okay, so look, I'll explain this because I mean it all ties into logic circuits anyway. Although I'm not going to do it all now because it is a little cumbersome for me to draw all these things. Okay.
Okay.
If I were doing a piece of paper and show you, it would be a lot faster. Maybe I'll do it for you. Okay. So this guy here. The way you do it is, you see how there's an equal sign here. What does equal sign mean? It means that this equation here is equal to this equation. How do you prove it?
Yeah.
This is an OR gate. You already know what the answer for an OR gate is. What's the output for an OR gate? 0, 1, 1, 1.
Yeah.
Okay. So basically, if you assemble this and you plot all your zeros and ones, your Y or your output should be the same thing, 0, 1, 1, 1.
Sorry, sir. If you use the truth table, I can prove. But I want you use the theorems to, how to say, to result from the theorems.
No, I don't understand.
You
okay,
only
so
use
you're
that.
saying...
You only use the theorems. You only use the theorems to prove the law.
You can't use just the theorems to prove the laws.
Oh, okay. I try my best. I can. Yes. If you use the truth,
No.
you can. Yeah, I know.
Okay, so we're good. You're okay. You know they work then.
Okay.
Look,
So, so how from what he get the laws? From where he got the laws?
write down this number. Write down this number. You ready?
Yeah.
Vincent?
Yeah.
Okay. 555,
555.
1, 2, 3, 4, 5, 6, 7. It's
4,
Mr. Boolean. It's Mr. Boolean's phone number.
Oh, no, you joke. No.
Vincent, look, this course is for electricians. You know how hard it is for me to give a course like this to electricians? You're like in another stratosphere. It's not covered in this course, okay?
Okay.
I already yesterday, I realized that for a lot of you, this was like way, it's something that, you know what I mean? You can't even grasp why we're doing it.
Okay.
First of all, it's not me that decides or everyone that decides. It's the Minister of Education that says you need to know logic circuits. Okay, so
Thanks.
let's get through it as painlessly as possible, even though it's impossible not to get a little bit of pain. Okay, so let's not beat a dead horse. Let's continue. So here I have a 1.
Wait, just one question. Can you,
Yes.
are you able to, do the simplified, simplify the unsimplified just one more time?
Man, you're giving me a headache this morning, guys. Simplify the unsimplified. I don't know. What do you mean?
Could you redo what you did before?
Okay, this guy here,
No, before, right before.
the factoring out.
Yeah.
Yeah. Okay, I'm choosing these two. Good, Ellie?
Yeah.
Okay, between this group here and this group here, what do I have in common?
The A naught. I mean B naught, sorry.
B naught. So here, I'm gonna write down B naught. Okay? And what I'm gonna do, if I remove the B naught from this group here, what am I left with? If I remove the B naught, what am I left with?
A naught plus B naught.
A naught. Okay. Plus, if I remove the B naught here, what am I left with?
A.
This is called factoring out. Okay. Now, factoring out and multiplying out are the inverse of each other. I have to be able to, mathematically, the reason why this works is because if I take B naught, if I work this out, I take the B naught multiplied by A naught, I'm gonna end up with A naught multiplied by B naught. If I take the B naught and multiply by the E, I'm gonna end up with A B naught. Okay, so I have to be able to go back and forth here. Okay, I have to be able to get back to this. Do you understand the factoring out and how it works? What you have to do, Ellie?
Yeah.
You sure?
Yeah. You find the similarities and
You factor them out, and then here in brackets, you write down whatever's left.
right.
Okay? Multiplying them out from here, I should be able to go back to here if you haven't made any mistakes. Okay? So, Ellie, I'm going to keep you on the line there. Look, I have A naught plus A. Is there a theorem? Is there a theorem where I can simplify this?
Yeah. T8.
With T8, where this becomes a 1. And I showed you why it becomes a 1. If you were to draw the OR gate, if A is a 0, well, A naught is a 1. If A is a 1,
Yeah.
you have one input that's a 1 for an OR gate, so the output is a 1. So I'm going to multiply that by B naught. I still have my B naught here. Now, Ellie, is there a theorem that can simplify this here?
The B naught times 1.
Yeah, but is there a theorem?
Where's B? Oh yeah. Which one? I don't know.
Don't look for a B though. Just look for a variable multiplied by 1.
Yeah. No. Wait. It doesn't have to be a naught.
No, doesn't have to be a naught. Look at T2. Any variable, A, B, C, Z. It can be a variable Ellie. Doesn't matter. Ellie times 1, it means there's only one of you. Ellie.
But why doesn't have to be a naught?
Any variable. this would work for any variable. So let me go one step further here to show you. If this is an AND gate, right, Ellie? Right? You see this guy here, multiplication?
Yeah.
Okay. So here what it's saying that if I have one of the inputs, which is a 1, okay, and let's just say I call this pin here Ellie. Ellie, today's Friday. Do you feel like a 0 or a 1?
0.
0. Okay. So Ellie, what's the output of an AND gate? So if I have an input that's 0 and one that's 1.
0.
0. Look here, Ellie. Look, Ellie. What was Ellie to start with? He was a 0. What's the output?
0.
0. Now, Ellie, because you're going to get a lot of sleep this weekend, Monday, you're going to feel like a 1.
All right.
So Monday, you're going to feel like a 1. Ellie, if you feel like a 1 on Monday, 1 and 1 in the AND gate, what's the output?
1.
A 1. So whatever Ellie is, that's what the output is. That's what this is saying. It doesn't matter what this variable is, this variable multiplied by 1 will always be whatever this is.
Yeah.
So you can just get rid of the 1.
Yeah.
Do you have a better understanding of how that works? So where it comes from. You don't really even have to understand where it comes from to be able to apply it. It's just there. Okay? But this is how it works.
Okay.
I can leave that there.
The 1 is always there, right? The other one, not the Ellie one, the B one, let's say. Because it's always there, whatever I am.
Yes,
whatever.
exactly. Yeah, so this is an AND gate, which is what this is. One of the legs is a 1, the other leg is whatever, a variable. Okay? So because what I've just showed you, the output will always be whatever the variable was. That's why it makes the 1 negligible.
Right, okay, fine.
Okay?
Okay.
So now I'm going to bring this B naught down. And I'm going to take this AB, and I'm going to bring this guy down. Okay, B naught plus AB. Is there a law where I can simplify that? I don't have to. You can stop right there and draw that one there. At the risk of complicating things even further, I'll just stop it there, okay? So after we've done that, I realize that's hard. I wasn't planning on spending this much time on this because I have a second method for you to simplify an equation. So, but it is what it is. I'm going to write it down. B naught plus AB. And like I said, no matter where you decide to stop, it's still a good answer, okay? Had you stopped right over here or right over here, it's still a good answer. The more you simplify, the less work you have ahead of you. You're going to use less gates, and it will take you less time to wire, and you're less likely to make any mistakes. So I have A, and I have B, and now I have to draw it.
Excuse me.
Yes.
The last answer is B naught plus AB, yeah?
Yeah, you can probably go a bit further, but let's go with this. Let's draw this.
Is it necessary to simplify it again?
It's not necessary.
Yes.
Like I said, you could stop here. You could stop here as well. It's not necessary, but it's always good to simplify as much as possible. Okay?
For example, according to the L6, if we want to B naught plus R multiple B naught plus B, the answer B naught plus R.
Did you say L6?
L6, yeah.
Law 6?
L6.
But it doesn't have a naught.
No.
L6?
according to the laws, L6.
Mohsen, I realize that you and Vincent are really good at math and you have experience with this, okay? But I have to go further with a more simplified version of the course, okay? This is not for engineers, this is for electricians. So let's just draw this because we have to practice and move on. So look, we have an A and we have a B. We have an A and we have a B. That's this guy right here, the AND gate. And then we have an OR. Okay. What are we ORing? We're going to OR with the B naught. We're going to take a B naught. We're going to invert. We're going to put a resistor in there. Inverter. LED, sorry, not inverter. So an LED with a little arrow. That's not an SCR, that's an LED. And grounded. Then what I want to do, if you go to the last page of that, or if you go to this document here, 3C pin numbers, we're going to look at the pin numbers. I'm going to start with the AND. Let's erase this.
So when it comes to drawing out the simplified equation, you're gonna have reference to the pin numbers?
Yes.
Okay.
Okay, I'm just cleaning this up from yesterday.
Also, when you're drawing it out, it doesn't matter. Can you do B naught plus A? And then.
No, bed mass.
Right, okay.
Remember bed mass?
Yeah.
Brackets first, then multiplication, then addition. Okay.
Right.
So this guy here, Mohsen, can you give us a hand, please? Mohsen, what number is this gate here?
2 gate.
What number is this gate here? The AND gate.
Yeah.
AND, if you find the AND gate, look, the number is this, 08.
08, yeah.
So it's a 08. We're going to use the first one here, this guy here, okay? So we're going to number this 08 because it's an AND gate. And then we're going to number it. What are the inputs?
1 and 2.
1 and 2, and the output is 3.
3.
So the input is 1 and 2, and output is 3. The next gate I have is this guy here. This guy here is a 32. So if I go to page number 4, my 32 is right over here. It's an OR gate. My first one is right here. So I have 1 and 2. I have 1 and 2. And output is 3. The gate number is a 32. I have a third gate. The third gate is a 04, which is an inverter. The inverter is right here, 04, where the input is 1 and the output is 2. So now when I number this, 1, and 2. And this is basically your plan for you to wire it up afterwards. So when we get back to school, we have to wire this up. I'll have to go through this again to show you what it actually means.
Okay, so the input is, I mean, it's 1 and 2, right? But like there's 3 and 4.
Are you talking about the inverter?
No, and on the pin numbers, right? There's 3, 4, and 5, and 6, but like they're all the same, right? Or
so again, are you talking about this chip here, the inverter?
Yeah, inverters.
Yeah. You can use 1 and 2. You could also use 3 and 4. You can also use 5. You can use one of these. What I highly recommend, eventually we're going to have big circuits with several of them, is just start the first one you see number 1, 2. The next one you see number 3, 4. So there's a certain logic to it. Okay, otherwise you're going to have numbers everywhere, and even your wiring eventually will be a mess. Okay, so just use the first one. I have 1 AND gate. Use the first one, 1, 2, 3. It'll work if I use 10, 11, 12. It'll work. It's not an issue. But just use the first one. 32. Use the first one, 1, 2, 3. That's it. Now, that's pretty much a revision of everything we did yesterday. Are we okay with coming up with this from this equation here? Not too bad. A bit more practice, I know.
Excuse me.
Yes.
The aim of this question is that to decrease the logical gate.
So the aim here is that you want to build something that responds to changing inputs in this way here. It could be eventually a card on rail, a sliding door. We're going to look at all these applications afterwards. Right now, these are just basic tools that we're going to need to simplify real life scenarios. Okay. Yeah. So this is a real life scenario, whatever it is. And it's saying, well, when I have this combination, I want it to be on. When I have this combination off. So build me a circuit that does this. Is everyone listening, please? This is a really good question, Mohsen. Okay. So build me a circuit that does this. Well, how do I go about that? Well, okay. Whenever there's a 1, that's when I want to activate this door or whatever it is. So this is the equation for it. Now I could build this with this equation here, but it requires more material. Okay, it's more costly. So let me save some money because that's what it's all about, right? You don't want to pay to have your landscaping done for $60,000. You want it done for $30,000. So try to get rid of some of these gates. I have your attention now, Sardi, eh? So simplify using the tools. The tools are basically what I showed you before with the Boolean algebra. These guys here. So now I have something smaller to build, which is more cost efficient. I build it. Well, what is the job of this? What is this going to do? Well, if I toggle A and B according to all these combinations that you see here, it will only be a 1 in combination 1, combination 3, and combination 4.
Yeah.
Okay.
So
Are we clear on what this does for now? Even though I haven't given you a real concrete example yet, because we're learning what to do first. Eventually, like I said, I'm going to show you card on rail, punch cards, real life scenarios. Okay, well, real life scenarios, loosely fitting. Okay.
Okay. Sorry.
Yes. Thank you.
No problem.
Sorry, sir.
Yes.
Excuse me, just 1 minute. Because I found the loss 14 is a little typo. I mean, a little wrong.
14, you have to be careful because you have, you have this guy here, add notes, this guy here.
Oh, yeah. You're right.
This guy here and this guy here, okay?
Yes.
Okay.
Yes, you're right. Yeah.
Okay.
Yeah.
Okay, so look, that's that wraps it up in terms of the recording for now. I'm gonna try to post this later on today. So you'll have this.